Hello, I'm Agapi Risaki, and I want to talk to you about our work on Agentic Schema Refinement. This is joint work with Nikos Vasiloglu and Elias Foudalis from Relational AI and Wolfgang Gatterbauer from Northeastern University. We are dealing with databases in the wild. They contain rich semantics, but it can be hard for humans to conceptualize because it is common to have structural complexities. For example, weird column names, tables too wide, different data sources referring to the same entity, concepts that appear in queries frequently but not stored explicitly. The question we ask is how can we enhance the semantic interpretability of these databases? Our solution is an intermediate layer between a user and the database that highlights the semantics and hides unnecessary complexities. We implement this semantic layer as a set of views, which are concise and easy to interpret. Our views augment the database since they are defined within it. This process can also be seen as a process of schema refinement that produces a practical normalization of the database. We discover these views via a process that we call query refinement. We start from a complex SQL query and we iteratively simplify it by defining subqueries. The collection of these subqueries form our set of views. This entire process, from coming up with the query to defining and improving the views, is handled by LLM-powered agents. The agents interact with each other in a simulation where they define views, they improve them through feedback, and then additionally, agents validate the views using external tools. For example, we can use an external database to syntactically verify the view definition and to enforce integrity constraints. We implemented this framework and we applied it to several complex databases. As a case study, we will use a database containing data from the Center of Medicare and Medicaid Services. The initial database contains 113 tables, a total of more than 6,000 columns, with the widest table containing more than 1,000 columns. The database is quite challenging to handle, as a simple textualization of the schema takes more than 95,000 tokens, which means that the modern LLMs cannot even ingest it all at once. Applying our framework, we produced around 600 views with a median width of 4 columns each. A further ER analysis of our views reveals a set of 36 discovered entities and their relations. Let's see a small snippet of the ER model, which shows a few discovered entities together with their properties and relations. Each entity and relation is associated with multiple views, and each view may pull data from multiple tables in the original database. To conclude, our semantic layer allows users to gain insight into the semantics of their database, and it's constructed automatically with an LLM agent simulation. Thank you.